Hi Calculus 1 students. This is a YouTube video in the section 4.3, the shape of a graph. And what it's asking us to do is to find the critical values of this function 4x to the 3 half minus 3x to the 1 half and apply the second derivative test for each of them or state that it fails. So first of all, just a reminder, what is the second derivative test? Let's actually write that in green. So reminder, second derivative test. So here's what it says, okay? If x equals c is a critical value for which the first derivative is equal to 0. So if x equals c is a critical value for which actually the second derivative exists, and that means that the first derivative must exist as well. Okay, so for which f prime prime of c exists, then if, and we have three scenarios, if f prime prime of c is greater than 0, it means that we have a relative minimum. If f prime prime of c is smaller than 0, it means that we have a relative maximum. And finally, if f prime prime of c is exactly equal to 0, then the test fails, hence my statement over here. So test fails. Okay? So very simple, what we need to do, we first need to find the first derivative. So, all right, f prime of x. Now this is a breeze, right? You've taken derivatives that are much harder than this. So here, 4 times 3 half x to the 1 half minus 3 times 1 half x to the negative 1 half. And the only reason I did this is that, as I can see, I'm going to simplify the 4 and the 2. So we're going to get 6x to the 1 half minus 3 half x to the negative 1 half. Okay? So this is the first step. Now the second step, remember, is to find the critical values. So this means that it's good if we factor any kind of common factor we have. And remember that this x to the negative 1 half is a common factor, and we factor the lowest exponent of it. So we're going to get here x to the negative a half of, so 6 times x, right? Because we know that this exponent is one higher than this one. We see it right away. And then minus 3 half. So, all right, from here, finding the critical values. So let's find the ones for which f prime of x does not exist, okay? And here I forgot to do one step before doing this, is that this should be simplified further. Actually, let's go down and do that step. Or we can actually just do it here. So look, this derivative is going to be 6x minus 3 half. And this is enough. Don't do more than necessary. Over the square root of x, right? So in other words, this is going to be x to the 1 half at the bottom, but we know that this is the square root of x. So f prime of x does not exist. So first of all, it does not exist at x equals 0. So at x equals 0. However, okay, so x equals 0 is not a critical value. And the reason is that it's a boundary point of our domain. Okay? So let's actually write this down. But it's not a critical value since So since it's a boundary point of the domain, or a boundary value if you prefer. So just as a reminder, the domain of square root of x to the 1/2, okay? I'm taking the x to the 1/2 that's over here, but x to the 3/2, it's the same domain. It is from 0 to infinity, okay? So we're like x equals 0, as you can see. We're talking about this boundary value. And remember that it is not a critical value. A critical value must be an interior point. So now let's push on. Let's see where the first derivative is equal to 0. As you can see, that happens when so 6x minus 3/2 is equal to 0. It's fairly easy to solve that equation. I must just be careful not to do any kind of mistake. So all right, 6x is equal to 3/2, which means that x is equal to, and it will be equal to 1/4, as I can see, because 3/6 is a half. So there you are. So x is equal to 1/4. All right. Now we got this. Let's erase the statement of the problem. But remember what we need to do. We need to apply the second derivative test to that critical value only, because as I said, this is not a critical value. So here we go. So step number 3 is to find the second derivative. And whenever you find the second derivative, be careful not to find the second derivative of this, right? Find the second derivative of that. In other words, always use the form of the derivative that is the simplest for the purpose of that calculation. So in other words, you're going to take the derivative of this thing. You see? So 6x to the 1/2 minus 3/2 x to the negative 1/2. And from there, what do you get? Okay, so pretty straightforward. 6 times 1/2 x to the negative 1/2 minus 3/2 times negative 1/2 x to the negative 3/2. Okay, now we do need to simplify this a little bit because we're going to replace values in that second derivative. More particularly, we're going to replace the 1/4. So we do need to be able to calculate, and this is not a very proper form. So, all right, simplifying this. Let's first deal with the numbers, because as you can see, they could be annoying. So 3x to the negative 1/2 plus 3/4 x to the negative 3/2. Okay, and from there, let's factor the 3 out. That is a common factor. Okay, so we will have like 3 times some things. That will help our evaluation. And let's also factor the x. So factor the common factor of x, and the lower exponent is right here. So we're going to factor x to the negative 3/2. And then let's write what remains. So what remains here is just x to the power of 1, because this power is 1 higher than this one. Plus the 3/2. All right. And then lastly, let's just say, okay, well, we have like our 3, our x plus 3/4 divided by, and what is this going to look like? Well, this, it's going to be, so what could we do here? Okay, yeah, I have an idea. So let's say that this is the square root of x to the power of 3, right? You first move it at the bottom. You're going to get 1/x to the power of 3/2. So in other words, it's the square root of x to the power of 3. The reason I write it like this is because it's much easier to first do the square root. It's going to give an overall smaller fraction. So here goes. Now I can erase all of this. So step number 4. So what we want to do is f prime prime of c for each critical value, but in this case, we have just one. So all right, we just punch in this 1 over 4 that we have here. And we have done all the preliminary steps. So the calculation is really easy, right? So here, 1 over 4 plus 3 over 4. So we're going to get just 1. And here, okay, be careful about that. Actually, let's slow down here. We put in 1 over 4. If you take the square root of this, it's like square root of 1 over square root of 4. So it's going to be 1/2. So in other words, we're going to get first the 1/2 to the power of 3. Now, this is easy to compute. It turns out to be 1/8. Okay, that being said, guys, keep in mind here that we only want to know if it's positive or negative. So you could actually just stop here because you know that it is positive. So, but there, it's actually gratifying, satisfying to say, yes, okay, the second derivative is 24. Point is, it is positive. And the reason I tell you this is because sometimes you're not going to be able to calculate the exact values. You're going to get some like weird square roots or stuff like that. But what's important is really to be able to tell me if the derivative is positive or negative. And because the second derivative is positive here, it means that f of x has a relative minimum. Minimum at x equals 1 over 4. And that's pretty much just what I'm expecting you to say. So this would be your final answer. Hopefully this helps. So see you either in class or in the next video.